And the width of the channel is 2 meters, so it's a rectangular channel. And the question asks us to calculate the upstream fluid number. So it's fluid number in section 1, the critical depth, so YC, and we know that the critical depth in rectangular cross-section is only a function of discharge. Then we need to calculate delta Z max. So we know what's the energy level in section 1. So we calculate E1, energy level in section 1. And then from that, we can equate that energy level and find out what is the delta Z max. And at the end, we would like to calculate Y1 prime if the hump raises by 20%. So what happens if delta Z max, whatever you delta max, Z max is, increased by 20%. So when you have higher delta Z, so you're going to have new delta Z, we call it delta Z prime, plus minimum energy due to the critical flow condition, and that gives you a new required energy level, which we call it E1 prime. Okay, so in the first step, we are going to calculate fluid number in section 1 for rectangular cross sections. So fluid number in section 1 is equal to V1 divided by square root of G Y1. Or I can also multiply that fluid number equation by area, so A1, which gives me, so V1 A1 is Q, so I have the total discharge, and then A1 is B0 Y1 times the square root of G Y1. So this way, instead of calculating the velocity at section 1, I can just calculate everything together. Okay, so total discharge is 2.5 cubic meter per second, divided by B0, 2 times 1.75 times square root of 9.81 times 1.75. And this gives you the fluid number of 0.172. So this is less than 1. So the flow is subcritical. So we have subcritical flow. So this is part A. So in part B, we would like to know what is the critical depth. So we calculate critical depth. YC is equal to cube root of Q squared divided by G. Okay, or I can write it in form of cube root of Q divided by B0 square divided by G. Okay, which is equal to cube root of 2.5 divided by 2 to the power of 2 divided by 9.81. And this gives you the value of YC equal to 0.542 meter. So in part C, we would like to know what is delta Z max. So using energy equation, so E1 is equal to E minimum plus delta Z max. Okay, so what is E minimum? So E minimum is 1.5 of YC in rectangular cross section. So for rectangular cross sections, E minimum is equal to 1.5 times of YC, and E1 is Y1 plus V1 squared divided by 2G. So both values are known, and the only unknown value is delta Z max. So here I calculate E1 is equal to Y1 plus, and for V1 squared divided by 2G, what I do is I multiply that by A1 squared divided by A1 squared. So that gives me Q squared divided by 2G B0 Y1 squared. So 1.75 plus 2.5 squared divided by 2 times 9.81 times 2 times 1.75 squared. That gives me E1 equal to 1.776 meter. So if you compare it with the depth 1.75, you will see that the contribution of the depth in respect to the velocity head is much higher. So that's mostly the case for subcritical flow. So I have E1 and then E minimum, I can write it here, is 1.5 times 0.542, which is equal to 0.813 meter. Okay, so here I have E1, 1.776 is equal to 0.813 plus delta Z max. So E minimum is the minimum energy required for the flow to pass over the hump. And the initial budget of energy is already calculated, 1.776. And the difference is the maximum hump elevation, which we can calculate here. Delta Z max is equal to 0.963 meter. So if you raise delta Z or the hump level to 96 centimeter and 3 millimeter, the water level at the upstream still is 1.75. But from the moment that you raise delta Z max, delta Z above delta Z max, then you're going to have backwater effect or choking effect. So in section D, we have delta Z prime is equal to 1.2 times of delta Z max. So the question is, what happens if we raise delta Z max by 20%? So definitely we are going to have backwater effect because we raise the hump elevation by above delta Z max. So delta Z prime is going to be 1.2 times 0.963, which gives you 1.155 meter. Now the new energy level, again using energy equation, E1 prime, or the new energy level, is equal to the minimum energy that we need plus delta Z prime. So here E1 prime is equal to, so the minimum energy level is 0.8131 plus 1.55 1.155 is equal to 1.968. So this is the new energy budget. And then we can write down the energy at section 1, or the new energy level at section 1, Y1 prime plus Q squared divided by 2G B0 Y1 prime square. So you'll see here that E1 prime is known. So E1 prime is 1.968 is equal to Y1 prime plus 2.5 square divided by 2 times 9.81 times B0, 2 times Y1 prime to the power of 2. So one equation, one unknown, you can either multiply the right-hand side and left-hand side by Y1 prime square to convert this into a cubic equation and solve for it, or you can use try and error to find out what is the value. So what I'm going to do is I'm going to use try and error methods. Okay, so here I have E1 prime, which is 1. So I have 1.968, and then here I develop the equation. So Y1 prime plus 2.5 to the power of 2 divided by 2 times 9.81 times Y1 prime square. Okay, so I start with 1.75. Okay, to see if I get the same value for Y1 prime. So Y1 plus Q is 2.5 square 2G Y1. And then, so it's 2.5, and then here I need to have 2 times. So here I have total discharge 2.5 to the power of 2 divided by 2G times B0 times Y1 prime to the power of 2. So you see that it gives you 1.776. So the E1 that we had from beginning. So this is how we double check. And now we need to increase to 1.96. So I'm going to increase the depth 1.8. So maybe 1.9, getting close, 1.95. So it's more 1.945.